All right, good morning, everyone. Today I'm doing a little bit more practice with all of the content that we're using to prepare for Quiz 6. All right, so here again, we're looking at angle, arc, segment relationships. So first up, I'm saying find the indicated variable, angle, or arc in circle O. And if I name it circle O, that means that O is the center of the circle. So I'm going to make a little note here just to remind myself that when we name a circle, we name it by its center. So in all of these problems, O is the center of the circle. Okay, so first up here, I'm looking at my picture and I can see what is marked. I can see that these two angles here are marked with something with X. So I need to think, well, how do I first solve for X? And then how do I get the measure of BRG? So I want this measure in the end. So when I look at it, I can see that, well, this is an inscribed angle vertex on the circle. This is its intercepted arc. For this angle, here it's also an inscribed angle. Its vertex is on the circle. It has the same intercepted arc. So we should remember that inscribed angles with the same intercepted arc, they have to be congruent. Let me write that up here. So inscribed angles with the same intercepted arc are always going to be congruent. So remember why. Right here, this angle, it has to be half of its intercepted arc. This angle has to be half of its intercepted arc. So if they have the same intercepted arc, we know that they have to both be the same measure. They're both half of that measure of the intercepted arc. So let me just show that these two angles here and here, they have to be congruent. So if the angles are congruent, we know that their measures have to be equivalent to each other. So I can build my equation by saying 1/2 of x plus 35 equals 2x plus 5. Okay, and then from here, I need to clear my fraction. So I'm going to multiply every single term by 2. So what I'm really doing here is I'm doing 2 around the package, and then I'm really just distributing to both of those items. So here in my next stage, I have x plus 70 equals 4x plus 10. So now I want to gather my x's on one side. So I'm going to subtract the x over to the other side. 70 equals 3x plus 10. Take away the 10. So 60 equals 3x. Divide by 3, and x gotta be 20. Okay, so x is 20. So now again, what the problem is asking, and I have to be very clear, I have to answer what the question is actually asking. I need the measure of BRG. So I want to plug in the 20. So half of 20 is 10, plus 35 is 45 degrees. I want to check over here to make sure that I match. So I know that I solve for x correctly. So 2 times 20, that's 40, plus 5, we're back to 45. Okay, so the fact that those measures match, I did something right. And I should also know, even though I'm not asking for it, that that minor arc, this intercepted arc right here, that has to be double the 45 to get to 90 right here. Okay, what was I asked for? I was asked for the measure of BRG, so right here, that measure was 45 degrees. All right, next up, here I have really have 3 intersecting chords. They all intersect at this point right here, but I didn't mark anything as O, so I don't have a center of the circle. So I have to build off what I actually know. So if I look at what I actually know right now, what interests me is that 65 right here. I can connect to its vertical angle right here, also 65, but then I need to figure out, well, why am I given those measures? There were only 3 measures marked, so building off those 3 measures, what can I connect to? I know that eventually, this is what I'm trying to get to. I want this minor arc right here. I want its measure, what I've defined as x. So if I look over at that 65, so here that vertex is inside of the circle. So I know that that 65 is going to be the average of 110 and this arc right here. So if I think of it as an average, I can actually do that in my head. So I know that 110 is 35 units away from 65. So if I take 65 and I deduct 35 units, then I know that 30 degrees would be right here. So again, I'm just trying to build off what I concretely know. So I try to fill in a gap there. Okay. So then I also think, well, does that help me? I'm not sure yet. I need to keep connecting some more dots. If I look at the 89 here, my vertex is on the circle, so that's an inscribed angle. And if I trace those pathways over to here and here, that means that the intercepted arc from here to here, right, that has to be double the 89. So doubling that 89 gets me 178 right here. And now I actually see, oh, that helped me. That's actually what helped me more than anything, because if I know that this part from here to here, this minor arc is 100, and I know that from here to here, this minor arc is 178, then I just need the difference between them to get to x. So 178 minus 100 gets us 78 degrees right here. So x is 78. So in a lot of these problems, you just have to see, well, how can I build off the numbers that are marked? This was kind of a dead end. That one actually didn't help us, but this connection helped us tremendously. All right, let me slide up. So here in my next picture, we're asked to solve for AC. So ultimately, in the end, this is what I want. I want the full measure from here to here. I want that full chord. So if I mark what I have right now I know that OB, so this full span here to here is 12. I know that E to B right here is 7. So if I know that this whole part is 12 and this part is 7, 12 minus 7 would get me 5 right here. Okay, so again, I'm just trying to make connections. So what I have right now, again, is I have a radius. So a radius connects the center to a point on the circle, and I have a chord. And when they intersect, they are perpendicular. There's my right angle right there, and this chord gets bisected. So I'm giving it a tick mark here and a tick mark here. So now, here I need to figure out how do I build off of that to help me get to this full measure here to here. Well, if I know a radius, I want to just point out that OB, that segment, was a radius. So if I know that OB has a measure of 12, then I know that any other radius has a measure of 12. So all radii are equal to 12. So if I draw in another segment here, that part is 12. So off to the side, let me draw out a right triangle, where here I have 5 and here I have 12. I'll call this part x. So here I can use Pythagorean Theorem to get to x. X will be this part, this longer leg right there. So here I have x squared plus 5 squared equals 12 squared. So x squared plus 25 equals 144. Take away the 25. So x squared equals 119. Solve by taking the square root. So here I'm going to search and search to see if I can break down that 119, but ultimately I can't. There's no pair of the same number that multiplies to 119. So x will be equal to plus or minus the square root of 119. But we know that we can't have a measure that is negative, so we are only interested in the positive. Okay, but again, I want you to be very careful. Okay, remember that you have to answer the question that's being posed. So right here, this measure is the square root of 119. So that means that this measure here must also be the square root of 119. So if I'm trying to capture the length of AC, I need to add those together. So square root of 119 plus the square root of 119, right? Those are like terms. They have the same radicand, the number underneath the radical. So I have 2 of the same item. I would write that as 2 times the square root of 119. All right, next up here, I have another circle, of course, and I can see that right here, O is my center, so I have a nice diameter right here. Okay, I also want to just keep my eye on what I'm trying to solve for, and I want the measure of BAD. So I want this major arc that wraps around from here to here. So again, got to make sure that I'm answering the question that's being asked. That's what I want. Okay. So if this is a diameter, it splits my circle into two semicircles. So right here, 180. And then up here, I see that this semicircle is being split into 4 equal parts. So I have those congruent arcs, and I have congruent chords, which lead me to the congruent arcs. So if I have those 4 congruent chords, I know that they're cutting off the same portion of the circle. So these congruent chords lead me to these congruent arcs. So I need to take that 180 for the semicircle, split it 4 ways, and that gets me 45 degrees each. So this smaller minor arc, 45 degrees, same here, here, and here. So if I'm trying to get to the major arc that I'm asking for, I want the measure of BAD. I can easily take the 180 and add those 2 45s. That would get me to 270 degrees. I could have also taken 360 and subtracted these 2 45s. That would have gotten me there a little faster. So 360 minus 90, right, here's my 90 that I'm talking about, would also get me to 270. All right, next up, back to our sector type problems. So here I'm saying find the length and the area of the sector. And remember that a sector is just like a slice of pie. So I'm looking at the length. So my length would be from here to here. And its area would be that space that is filled in, that shaded region. Okay, so let's start with length. So length. Length is really just a portion of the total circumference, right? That total span that wraps all the way around the circle. We know that circumference is like the perimeter of a polygon. We just don't have edges for a circle, so we call it something else. So to get to the length, first I need to know what is the ratio of arc to circle. So I'm looking at that degree measure to 360, and then I multiply by the circumference, the 2 pi r. So in this instance, that degree measure here, that central angle that's 60, means that this minor arc, its intercepted arc, also 60. So I'm looking at the ratio of 60 to 360. Multiplying that by 2 times pi times a radius of 12. Okay, now I just have to clean it up. So I'm looking at 60 to 360. So that's 1/6. So my arc makes up 1/6 of the entire circle. So now I multiply that by the circumference, which is 24 pi. So really I'm taking the 24 and dividing it by 6. So that gets me 4 pi. So my length here is 4 pi units, right? There were no units specified, could have been inches, centimeters, etc. All right, next I'm looking at area. So I want the area of the sector. So the area of my sector, again, it's a portion of the total area. So I need the ratio of the sector to circle, and then multiply that by the total area, pi r squared. So when I plug in, I get 60 to 360 times pi times 12 squared. So my sector will be 1/6 of 144 pi. So my sector makes up 1/6 of the entire circle, and my entire circle has an area, right, total area of 144 pi. So when I take 144 and I split it 6 ways, I get 24 pi. So my area is 24 pi units squared. Okay, problem 6. So here I'm trying to get to the area of the shaded region. Sometimes we call it a segment. I think it's more clear just to say shaded region and think, how am I getting to that shaded region? Well, I should know that my shaded area, let me write that first, my shaded area, the area of the shaded region, how am I getting there? Well, I can see that I have a sector, right? This whole chunk is a sector, so that slice of pie. So I'm going after the sector, and I have to take out that hollow triangle. I always like a master plan. So my plan here is sector minus triangle. So if I visualize that, right, here's my circle, here's my sector, and I'm going to remove this triangle right there. And I'm left right here with my shaded region. That's what I'm trying to get to. So I'm looking at sector, but take away that triangle. So my sector, again, is a portion of the entire circle. So I'm looking at a portion of the entire area. So if I go after my sector first, area of the sector, again is the measure. So here we're looking at the degree measure of the sector. So right here we see 90 degrees. Okay, the arc here would also be 90 degrees to 360, but I'll fill that in just a moment, times the area pi r squared. So my sector here is that 90 that I just said to 360. So I know that my sector really makes up a quarter of the entire circle, and I have to multiply by pi times 6 squared. So I'm looking for 1/4 of 36 pi. So I want 1/4 of the total area, which was 36 pi. So that ends up being 9 pi. So my sector has an area of 9 pi square units. Okay, now I need to focus on the triangle. So if I look at the triangle, I'm doing half base times height. I can see that it's a right triangle. So right here, I know that my other leg has to be 6 as well. Right, my legs here are both radii, and any radius will match any other radius in my diagram. So my base and my height, those two perpendicular segments, my legs, are both 6. So my base and my height are both 6. So half of 6 times 6, if I multiply across, half of 6 is 3 times 6, and I'm at 18. So I have 18 square units for my triangle. So when I put it together, I'm going to get 9 pi, that was my sector, take away 18, and then write in the end, units squared. So this would be exact. Okay, if I wanted it as a decimal approximation, I could always plug into my calculator. So here if I say 9 times pi, just like that, and then take away 18, right, that would get me the approximation of 10.27 square units. Okay, you know that I always prefer an exact answer. I like seeing the answers in terms of pi or in terms of a simplified radical. All right, we got one more page. So please either flip it over or pull out that second page right here. All right, so my next one here, I'm asking for the measure of ME. So again, my eye is always on the prize. I want to get to this measure right here. So when I look at my picture and I think, well, how do I get there? How do I approach it? Well, I have to think about what is it I can actually solve for right now. So right now I see that I have an angle with its vertex outside of the circle, and I'm given the larger of the two intercepted arcs. So what I can solve for right now is this portion right here. I'll call it x. So I know that my angle, that's 25, is equal to 1/2 the difference between the intercepted arcs. And it's always the big one minus the little one. So 110 minus x. So now here, I want to clear my fraction. I want to multiply each side by 2. So now I have 50 is equal to, this just becomes 1. So 110 minus x. Okay, I'm trying to get to x, so I'm going to subtract 110 away from each side. So negative 60 equals negative x. Divide that negative 1 away. And x is 60. So right there, that is meant to be 60 degrees. Okay, so now I'm one step closer to what I want. And what I want, again, is the measure of arc ME. So when I see what I have, I know that the whole circle is 360 degrees. So this entire circle, 360 degrees. I've already used up 110 and 60. So I've already used up 170 degrees. So I need to think, well, what's left over? So if I take 360 and I subtract 170, I'm left with 190 degrees. So I know that what is left over, so this arc's measure and this arc's measure have to both sum to that missing 190. And since I see that I have these congruent chords here, then I have congruent arcs right here. So I'm just going to take that 190 and I'm going to split it 2 ways and get 95 degrees. So these measures here and here are meant to be 95 degrees. Not perfectly drawn to scale, but you know I do the best I can. All right, one more before the circle puzzle at the bottom. All right, so here looking at problem 8. Here we're told that the measure of DBC, this angle right here, is 40 degrees. I know that that is an inscribed angle because its vertex is on the circle. Okay, I know that the measure of AEB is 110. And I also know that the ratio of AD to BC is in a 9:5 ratio. So I don't know what the measures are exactly, but I know how they're related. And we've seen this strategy before. Let's apply a multiplier so that we can maintain the same ratio and be able to solve for their measures. So the multiplier I'm going to use is x. It's typically what you see me use. So I'm going to say that this is 9x and this is 5x temporarily. I'll be able to solve for x in just a moment. My goal is to find the measure of p. So this is what I'm going after in the end. So again, I always have to really think, what is it I'm trying to solve for in the end? Okay, so now connecting some of the dots. So building off some of the angles that were marked. So if I build off, say, this 40 degree right here. So I know that this 40 degree right here is the inscribed angle, and this is its arc right here. So I have this arc at 80 degrees. Okay, so now I'm trying to see also another connection that I can make. And I can see that right here, if that's 110, I know that its vertical angle would be 110. And I know linear pair here would be 70 and 70 here as well. I'm trying to make as many connections as possible to help me fill in the gaps. Okay, so now here with what I have marked, I can see that I have a vertex of this angle that is inside the circle. So I know that where that 70 is, let me focus on this 70 for a moment, right there. That 70 is the average of its 2 intercepted arcs here and here. So I know that 70 is equal to, again, the average of these 2 intercepted arcs right here. Another way to say that is 1/2 the sum. So 1/2 of 9x plus 5x. So I have my equation now, so I can solve for x. Once I have x, that will lead me to these 2 arc measures. So right now I have 70 is equal to 1/2 of 14x. So 70 is equal to 7x. Divide by 7, and I get that x is 10. Okay. So that was super helpful because now I know that this arc measure is really 9 times 10, so 90 degrees. And this arc measure is 5 times 10, so 50 degrees. Okay, so I just want to double check. So do I have arcs here and here that are still in that ratio? Is a 90 to 50 ratio a 9 to 5 ratio? Well, yeah, absolutely. If I just divided away what I used as my multiplier, if I divide each of these by 10, I'm back to a 9 to 5 ratio. Okay, so now it's a matter of answering the question, right? I filled in a bunch of missing parts, and now I just have to answer the question. So angle P. Angle P, the vertex is outside of the circle. So I need to trace it up. I need to look at what its two intercepted arcs would be. So if I trace it up, I have this small one. But if I go up to here, I have this as my big one. Let me make sure that we see that really, really clearly. Let me see if I have another color. I have black. Okay, so if I trace this up, here would be the smaller of the two intercepted arcs. And then if I trace it up to here, this would be the larger of the two. So here's my larger one from here to here. Again, just want to make sure you see that clearly. I'm tracing it all the way up to here, right? That farthest point where it intersects the circle, here. So that larger arc is 170. And if I trace it up to here, that smaller arc right here is the 50. So I'm saying that the measure of P will have to be half of 170 minus 50. So half of 120 will get me 60 degrees. So measure of P is 60 degrees. All right, last one, circle puzzle. Okay, I love these. I wouldn't assess this way, but I like having you practice with these problems. I feel like it gives you just good practice in connecting the dots, connecting your skills together. And in these problems, there's really multiple paths that you could take in order to connect those variables that I'm asking for. And I love that. I love that you can see a totally different pathway than I see, and we can still land in the same end result. Okay, so let's see what we got to start. So the first number that I see right now is 25. Okay, I also know that this is the center of the circle. I didn't explicitly state that, so I'm telling you that right now. So there's the center of the circle. Okay, so if I build off this angle right here of 25, so I see, okay, vertex is on the circle, so its intercepted arc is from here to here. So I need to double that 25 to get to 50 degrees right here. So I actually know what G is right away. I know it's 50 degrees. Okay, I also should see an isosceles triangle. So I should also know that any radius is congruent to any other radius. So if I mark a tick mark for each of those radii, that helps you to see any isosceles triangles a little bit better. So here is an isosceles triangle. This would be the vertex angle right here, and these would be the two base angles that have to be congruent. So right here, this angle has to be 25 degrees. So if my two base angles are 25, I've used up 50 degrees. So my triangle has to sum to 180. So 180 minus those 50 degrees leaves me with 130 right here. Okay, if I connect to its linear pair, where A is, I now have 50 degrees for A as well. We're going to see a lot of 50 degrees for angles and arcs in this problem. All right, so now I just need to keep wrapping my way through. Here I can see that this pathway, the pathway that I draw as straight like that, that's a diameter. And then I also have a diameter here. That can be helpful in two ways. That can help me identify semicircles. That can also help me identify any vertical angles. So if I build off of my vertical angle here, that's 50. Right here would be 50 as well. Okay, I can also see another isosceles triangle right in here. So if I have this base angle at 50, this base angle would also have to be 50. Okay, and then that adds to 100. So my missing angle right here, the vertex angle, would have to be 80 degrees. Okay, and then if I fill in this missing measure right here, I've got a straight pathway. So these three have to add up to 180. So I have 50 degrees right here. All right, so I filled in all of those central angles, and now I want to work on all of the intercepted arcs. So if this central angle is 130, then its intercepted arc here would be 130. Okay, if I look at this central angle 50, its arc, intercepted arc, would be 50 here as well. So I know what n is. N is 50. Okay, if I look right here where the 80 is, trace it over. This is its intercepted arc, 80 degrees. So M is 80. Okay, where that 50 is, trace it over. That's its intercepted arc, also 50. So H is 50 also. Like I said, there's lots of 50s in this problem. Okay, so now I need to look for something else. So now I see, okay, I have a couple tangent pathways. So here I see that we're touching the circle in one location. This is a point of tangency. And we should remember that when we have that tangent pathway and we have a radius, they are perpendicular. So right here would be a right angle, and right here would be a right angle as well. So then I know what F is, right? F has got to be 90. Okay, I'm not asking for it, but I'm just going to fill in this part too. So this whole angle has to sum to 90. So 90 minus 25 will get me 65. And that makes perfect sense because here, vertex on the circle, that angle has to be half of its intercepted arc right here. That was 130. Okay, keep working my way through. So for J, here again, I see another tangent pathway. Here's that point of tangency because here's a radius touching at that one spot. So where J is, we got another 90-degree angle. Okay, and this is a 90-degree angle right here. So if I go after K, I know that together these angles have to sum to 90. So if that's 50, then this part has to be 40. But I could have also seen that because, again, vertex here on the circle, this angle has to be half of its intercepted arc. So K is 40 degrees. Okay, I didn't really build off of the parallels in this situation, but I could have. So I just want to point out one pair of parallel transversal relationships, just a nice refresher of something we did a while ago, but it keeps coming back. So if I see a parallel pathway here to here, again, I can always sync up here to here alternate interior angles. So I can also build off my knowledge of, parallel transversal relationships. If I was asking for an angle out in here, I can build off my triangle relationship, right? I know that this angle would have to be 40. I could also have said here, this angle, right, would be 1/2 the difference of the two intercepted arcs. So I could have also gotten there by taking 130, right here to here, 130, take away the 50, so I'm at 80, and cut that in half, I get to 40 that way. If I wanted this angle, right, it's also going to be 40, but let me show you why. So again, I could see a triangle that has to sum to 180, or I can go to the intercepted arcs. So I have this intercepted arc that's 130, this one is 50. Difference between the two is 80, cut in half, I'm to 40 right here. So there's a lot of other little connections that we could make, but we have filled in all of our gaps to the right, so we are good. All right, hope you guys are doing well. Have a good rest of your day.